Alright, so I think I'm recording here. We're taking a look at skill packet 3, which is relations and functions. And in skill 3E, we are looking at how to create new functions from two old functions, how to build a new function. And we can do it through addition, subtraction, multiplication, division, and a new operation that we'll be looking at soon called function composition. But not only do they want us to add these functions together or subtract them, they want us to find the domain of this new function, the resulting function. And what's pretty amazing is that you can find the domain of that resulting function actually without ever finding the equation. I don't have to add f and g together to find the domain of this new function f plus g. I can take the domain of f and what they call intersect the domain of g. We've seen the idea of a union where you're in this interval or you're in a second interval, but with the idea of intersection, you have to be in the domain of f and be in the domain of g to be in the domain of this intersection f plus g. So to find the domain of a function given an equation, we've seen this many times now. It's the set of all real numbers excluding any values that cause division by 0 and excluding any values that cause us to take the square root of a negative number. So that's what I have here as a square root. And this 25 minus x squared is a little bit different than other inequalities you've ever looked at, because the other inequalities you've looked at have always been x to the first power. With this x to the second power, we call this a quadratic inequality. And there's two ways that I can think of to solve this. There's one that is algebraic, and then another using the graph. What does 25 minus x squared look like on a sketch of the graph? I think that students do better with the algebraic way. So that's how I'm going to present it here. I need the right hand side to remain 0. We need to avoid the temptation. We're not getting x by itself here. We're not going to solve for x. We're going to factor this, and 25 minus x squared factors to 5 plus x times 5 minus x. Well, the 5 plus a negative 5 gives me 0, and 5 minus positive 5 gives me 0. These negative 5 and positive 5, they will often be referred to as critical points, or maybe boundary points, because they're going to take my real number line and divide that real number line into 3 sections. And I could call it sections 1, 2, and 3, or what I'm going to do is just call it section A, section B, and section C. You can call it, any 3 names that you want. In A are all the real numbers that are strictly less than negative 5. In B are all the numbers that are between negative 5 and positive 5. And in C are all the real numbers that are strictly greater than 5. So let's pick a random point for A, but one that's easy to do arithmetic. So I'm going to pick a test point, and I'm just going to pick negative 6. It's smaller than negative 5, and it's going to be easy for me to do arithmetic on. The easiest number that's between negative 5 and positive 5 for me to do arithmetic on is 0. And for in region C, a number that's greater than 5 that would be easy to do arithmetic on would be a positive 6. So I'm going to return to this quadratic inequality, and I'm going to kind of look at it as a true or false statement. I'm going to let x be negative 6. So if x is negative 6, I have 25 minus x squared. 25 minus a negative 6 squared. Well, the claim is that this will be bigger than or equal to 0. But 25 minus 36 is not. That's a false claim. So all of the numbers here are not solutions to this inequality. They do not satisfy it. The values that you plug in for x will not be greater than or equal to 0. Well, what about if we let x equal 0? We're going to have 25 minus 0 squared. and that is 25, and 25 is bigger than or equal to 0, that's a true statement. And it turns out that any point that I pick in region B will be a true statement, so I'm going to keep that in my solution set, which means it's going to be in the domain of f. All of the numbers that are between -5 and +5, if we plug them in, we'll get we'll get 0 or a positive number to take the square root of. Now what about a number like x equals 6 in region C? We can see it's going to fail just like it did in region A, that if x is equal to 6, we have 25 minus x squared, which is 25 minus 6 squared, and there's no way that 25 minus 36 is a positive number. It's not greater than or equal to 0, that's a false statement. And it would be false for any number that we picked for any test point in region C. So the domain of f is the set of real numbers that are between -5 and +5. My domain of f, if I draw a picture of it, is between -5 and +5. And all the numbers that are between there. Well, let's come in and take a look at the domain of G. G does not have any square roots, so I don't have to worry about taking the square root of a negative number, but G does have a variable in a denominator. Is there any values of x that if you have x squared minus 4, that'll ever equal 0? Well, yeah. 2 squared is 4, and -2 squared is 4. So if I factor this to x plus 2 times x minus 2, I can definitely see there's two solutions to this second degree equation. Being a second degree, I was expecting two solutions. So -2 and +2. -2 and +2 are inside my region of -5 and +5. That's going to be important to notice here in just a second, because we do not want our domain for G or the domain of f plus G to contain -2 or +2. So if we exclude -2 and +2, none of these other values were solutions to that. None of these other values cause division by 0. So my domain of G is all real numbers excluding -2 and +2. Well, now I'm ready to find the intersection of these two sets. To be in the domain of f plus G, you have to be in the domain of f and you have to be in the domain of G. So if I draw a picture here and include these numbers -5 and -2 and +2 and +5, is -5 in both domains? Are they in both sets? Yes, so they'll be in my intersection. But -2 is not in both. It's in the domain of f, but it's not in the domain of G. And 2 is not in the domain of G, so it can't be in the domain of the intersection. It has to be in both to be in the domain of intersection, like 5. 5 is in the domain of f, and 5 is also in the domain of G, so it's in my intersection. Well, to the left of -5 is not in f, so it won't be in my intersection. But if we look at values that are between -5 and -2, they're in both sets, and between -2 and +2 are in both sets, and values between +2 and +5 are in both. But values bigger than 5 are not in f, so it won't be in the intersection. You have to be in both to be in the intersection. So the domain of f plus G is from -5 to -2, excluding -2, or, see, here it was and, but now I'm back to or. Either the number's in this interval or it's in the next interval. That's why I need a union here. Or from 2 to positive 5. So I hope that helps. I believe this is the last one. So I'll make another solution of our next homework set to put on Edpuzzle. Hope that helps, and I'll talk to you later.